Yeah, good afternoon to all of you. How many members are there? Okay. I must first confess that I'm not in my hometown, and I've come for something called the Cool Conclave in Indore. We have a phenomenal 2,000 odd delegates, paid delegates who have come from across the country. Only 20% is from Indore. It shows us something. There are these 5, 6 agglomerations, and people like Nagesh ARAS belong to one of those 6 agglomerations. And many of you come from this horror called NCR. Forgive me for putting it that way. I keep telling JAIN that this is a gas chamber. NCR was a beautiful part, of India. If you went back even to 1980, I think it was a very livable city. Something went wrong, and some parts of of this jigsaw are to do with water, some to do with energy, some to do, of course, with housing, mobility, and so on. You are all experts in some ways. And I'm happy to have youngsters here, young Indians, whose aspirations are very different from those of people like me who grew up here, in the early 1970s, when India had probably one half the population that you today have. I remember a film of Amitabh Bachchan called Diwar, where he talks about 65 crore, and that's 650 million. And you know what Modi has been saying, and you all know what the population is today, clearly at 1350, 1400 million people. What is the good news here in all of this? Is there optimism for our cities? What is it that is missing? Are there things that we need to do on city infrastructure? Today's discussion is on city water infrastructure. But what are those things that we can do as citizens? What are those things that we can seek from local administrators and such? Nagesh ARAS is one of those thinking individuals who has been, reflecting on these concerns for quite some time. He writes about these issues. He brings a compelling argument on how there are things that can be done by you and I. Yes, you and I as citizens and as water users and energy users, and those that can or have to necessarily be done by governments, state government, sometimes the urban local body, sometimes the central government, and so on. I heard him, must have been about 2.5, 3 months ago, reflecting on some of those things, and he emerged with some 5 or 6 very crystal directions that I think every city needs. And I told myself that I will have to bring Nagesh ARAS to this very distinguished forum that we have of the PREM JAIN Memorial Trust, which was first, of course, set in memory of, our beloved Dr. Jain. And now, with the effort that Payal Jain has made, indefatigably over the last 7 years now, from 2018, what has happened is that many of you have joined who are running colleges, who are teaching students, and then, of course, students themselves who are here present today. I must first welcome students, and I will tell you all, it's very, very important to listen to not just one Nagesh ARAS. You have to listen to all of those people who have spoken on this forum over the last, I think, 37 or 38 months. And every month, unfailingly, the foundation has brought one distinguished person who has shared thoughts and reflections, insights and perspectives that are very important for you as a young Indian to learn. And then, of course, I want to address and greet all of you who are teachers, faculty members. You have got putty. You've got, you can shape these minds. It's a rare opportunity, and it's a blessing to be a teacher, as Dr. Jain used to often say. He never wanted to be known as a consulting professional. He always wanted to be known as a teacher, and he would beam with pride when somebody introduced him as a teacher and not as a consulting professional. So what I will do now is I will request AKASH to possibly speak on what you expect. What is your expectation of a meeting like this when somebody talks about city and water infrastructure? What do you think your students should gain from such a session? If you can capture that in, say, 60 seconds, that'll help us. And then, of course, after Mr. Nagesh ARAS speaks, I will ask you to see if you can respond to whatever he will be presenting. Over to you, AKASH.
Hello, sir. Yes, good afternoon.
Good afternoon.
Yes, sir. Actually, this particular topic is like we are basically from chemical engineering department. So in our perspective, we are telling regarding the topic fundamentals of water infrastructure. I think we are more into this water treatments, such kind of aspects than into the infrastructure. Like mostly like chemical engineering discipline point of view, we will be having 2 aspects. One will be the designing session of the water treatment plant, and other one will be like after the treatment, like post-treatment things. So like in regarding our department point of view, like we are doing actively, our research work is mostly on water remediation technology. Like we are focusing on catalysis, other advanced oxidation process, adsorption. So we are more into the remediations of recalcitrant pollutants like pharmaceuticals. Some faculties are working on dairy wastewater. Then few are working on soil remediation. So so then into the infrastructure side, I think we are working more on the remediation aspects. So this topic is like for us students, I think this will be pretty new topic because they have, I think they have mostly heard about as I told, the remediation things. So regarding the infrastructure things, I think it will be new aspects for all of us. So that we are looking forward more to know about these things, like into the infrastructure point of view things.
Very nice. Thank you for articulating it so well. I'm sure the speaker is listening to you and he will respond to you. Dr. ANSHY, anything quick from you? Anything that you think your students...
Yes, yeah, I would like to just add to what Akash has said. So, but still, as chemical engineering, I think it's very important to know and we all know the relevance of city water infrastructure, like to ensure access to clean water, promote conservation, and even to protect the ecosystem. So, though it is from different point of view, I would urge all our students to attend keenly to this lecture and know more about the city water infrastructure. I think it is going to be a very knowledgeful and insightful lecture. Yes.
Nice. Very nice and wonderful to have such a large turnout. I can obviously see that you have persuaded all your students to be part of this. Thank you for being here. Niranjan Khatri is a green champion of many, many years. I'm privileged to have him as a friend for at least the last 25 years now. He used to be part of the ITC hotel chain, and he's here as a member. He will speak at the end at some point of time. And he also knows Nagesh well enough. Okay, so that's, shall we say slot one, that's done. Nagesh, the time now is what? We're 7 minutes past the hour. You can take your 35, 40 minutes or whatever you think you're convenient, comfortable with. And then we will open it for some questions from the students. I'm hoping that more than questions, students will come up with ideas. I would love to see a student here who will say, Mr. Nagesh, sir, you're wrong with what you're saying. We'd like to see if there's someone who will sit and differ with you. Over to you, Nagesh.
Thank you. I'll straight away start with the presentation because I have about 30 slides, although, I was told that the students are from the architectural wing. So I had actually, prepared that slant. We do have presentation for the chemical and, the water body health related, health index related presentation. But unfortunately, I don't have those slides ready. So we will go through this and then we'll see how we can discuss about those issues as well while I talk. I'll try to bring in those topics. So today's topic is about city water infrastructure, the challenges and solutions, proposed solutions. If anybody has any problem, I suppose there will be some moderator who will actually find out what are the doubts or problems, and we can have that either internally inside the presentation or at the end. I leave it to Dr. Hariharan. So let me start then.
Please.
Okay, so I think I will skip this slide, but I'll just make a flash slide. Actually, I had actually talked about, and maybe the attendees can actually see whether this meets their expectation as well. So first thing is what we are going to do, talk about is sustainable design. That is, they integrate water conservation, rainwater harvesting, grey water reuse into projects. Project in the sense the new projects which are coming up, building projects or built environment projects and things like that. Now, I do not know whether the chemical engineers get that type of chance in the professional field, but it's something to think about. Another one is urban resilience. That is the plan buildings and cities to handle floods, droughts, and climate risks. Third is policy awareness. This certainly applies to everybody. Understand water laws shaping construction and infrastructure. Fourth is systems thinking. Link architecture with engineering, ecology, and governance. Fifth is community focus. This also applies to even chemical engineers, and that is design with local water needs and stakeholder inputs. There are about 13, 14 stakeholders. We'll see who are they, and we have to keep them into picture. So when, as engineers, we think about solutions, those solutions may not be acceptable to one or more stakeholder categories. So we have to actually take them on board. We have to sell the idea, and then we have to make that work along with the community. And last point is real world cases. Learn from the whatever is going around in the world as a successful water sensitive urban designs. So this was my plan to run. Let us see how we can actually change it as the need arises. So first we see water sustainability at city level. What do we mean by that? So first point is stormwater and flood management. Both are different. Stormwater is normal water disposal, and flood management means there are floodplains in any natural terrain, and we have to actually deal with those floods, and that management we have to see. So runoff water actually we have to handle. Flood prevention and mitigation. Third point is large scale retention and detention system. So that also becomes one of the topics. Sustainable drainage system deployment. Okay, so this is one of the the agenda what we have to do in the stormwater and flood management. Then water quality and ecosystem health. I believe this audience particularly may be interested in this topic more. That is the water quality improvement in bioremediation or even chemical remediation and things like that. Constructed wetlands, natural wetlands, and bioretention systems, biodiversity enhancement via water ecosystems, infrastructure and design. That is permeable pavement and surface adoption. In some countries now they have, say, permeable roads also, things like that. Rainwater harvesting and reuse, green-blue infrastructure implementation, infrastructure retrofitting for sustainability, public spacing with floodable and water features. That means, some parks are designed intentionally lower than the surrounding areas so that they can be flooded during a flood situation, but the park will not be damaged because of that. That is called a floodable park. And urban water cycle integration. And finally, climate and environmental adaptation. Now our city also has, it is participating in a multinational initiative in this climate climate change. This one, so we can play a part in that. Although the city administration has not invited public participation, but we can actually take initiative and get involved. So one thing is urban heat island mitigation through water features. Just an aside, actually, IISc had conducted one experiment where they flew drones across the city, across Bangalore in different directions, and they found that wherever there are lakes, the temperature actually drops up to 5 degrees Celsius. So this is the impact of water bodies. So this is what we are talking about, and climate adaptation and resilience plan. And finally, policy planning and community. That is water sensitive urban design frameworks, policy driven water absorption initiatives, integration of water with urban planning. Because right now we do not have urban plan in the sense of land use plan or land use policy. So we should be talking about land use policy which talks about water bodies as a center, core elements which are we have to protect and we have to respect. I will come to that in the later part of the presentation. Community engagement in water management. There are different stakeholders, as I mentioned. Monitoring and maintenance of water systems. Once, say for example, lakes or drains, they have to be maintained continuously. So all that has to be brought into the at city level. We have to talk about it. Now, let us look at the global scenario. What are the water resilience ideas and from where we can adapt? So globally, there are multiple ideas. So the one is in the US and North America, basically. That means US and Canada. It is called LID. We'll come to the full form. Here in Europe, there is SUDS, water sustainability based urban development, and green and blue infrastructure. In China, there is the idea of sponge city. And in Australia, again, the WSUD, that is the common between Europe and Australia. So these are the main ideas which are going around the world. And I will be talking, just an overview of these ideas. What are they? Their comparative analysis. And then I will be talking about what is happening in India and in Indian cities in particular. So first of all, we have to see how these water resilience approaches, operate vis-a-vis scale. So I will be listing the approach, and then I will be comparing in different scale. The scale ranges from plot to locality to city to region to country. So this is the picture. The various initiatives which I highlighted in different parts of the world, they are spread like this. So most of them are applicable to plot and locality level, but the sponge city, which is in China, it is at higher level, and that is the city, region, and country. But otherwise, most of the other approaches are at the lower scale, basically. They extend up to the city, not beyond that. Now, what are the design elements which actually go into these approaches? There are many overlaps, but let us see what are the design elements which go into that. So I will be talking about each design element, and we categorizing them into infiltration. That means water taken to ground. Retention, that means water actually is held for a certain time before letting it go. Vegetation based, where vegetation is allowed to grow. Storage of water or ecological enhancement of lake and other water bodies. So these are the categories, and this is the C. Okay, there are permeable pavements, infiltration trenches, infiltration basins, and detention basins. And these are actually infiltration based. Then for retention, there are 4 different elements. That is detention bases, ponds, floodable parks, and sediment bases, and silt fences, also called silt traps. So these are basically meant for retention based policy and infrastructure. Then comes vegetation based. All these on the left, actually, they are all vegetation based initiatives, including construction wetland and natural wetland also you can come. Okay, so these are the things which go into that. And third category is storage and ecological enhancement. So storage is rainwater harvesting and reuse, water storage sumps, rain barrels and cisterns are storage based, and urban park with water features and blue corridors, that is river, canals, drains, major rajkal waste, all that goes into ecological enhancement. So these are the categories of different elements which are used in the initiative which we talked about. So let us see what are the approach versus design elements. What type of design elements are used in which approach? So again, design elements is on the left column, and all the approaches are shown in the right. So this is the kind of deployment we are talking about. I will not be talking about details because the audience is chemical engineers, not architects. So I will skip the details about this. Now we talk about water resilience in Indian cities because we are not following any of those approaches per se. So we have our own method, or rather, it is in the nascent stage. So we have to talk about setting up these approaches and following our own method, which resonates with our people, our cultures, and our cities, whatever the unique needs we have. So the outline of this part is we will first define the water system as applicable to a city. Then we will talk about problems in our water system. Then we talk about root causes of these problems. And then we talk about solutions. Then finally, required governance system. See, so finding solutions and talking about solution is not enough. We need a governance system which involves both the government and the public. So, together we, run the system, we cooperate, government and public. Public also involves businesses, industries, everybody. And then we, maintain that system. So that is the basic idea about it. So first part is to define water system as applicable to Indian cities. So we talk about water system assets. So far, nobody talked about assets because it was not thought about as different assets. So what are the different assets which play, which are components of our water infrastructure in the city? So we basically talk about, on the left, these are the generation of pollution, generators of pollution. That is individual houses, standalone houses, apartments, industry, a standalone industry, large industry, or a cluster of industries in a complex, in a industrial estate. So how the water flows in that is from houses, different individual houses. It goes to underground pipeline. UGD means underground. And it goes to BWSSB STP. That is the public STP. For different cities, if you are not from Bangalore, then you can imagine your own water body, the board which supplies water and treats the sewage. So they have their own STP, public STPs. From that, it gets, all the water, all the treated sewage actually gets converged. It converges into common pipeline. From apartments, they have their own STPs, larger apartments, and so their individual private STPs also treat sewage and they contribute. From industry, there is industrial effluent, and they have effluent treatment plant, and that treated effluent actually merges with the flow. Then the industries which are in the industrial estate, they have central ETP, that is a central effluent treatment plant. Again, the treated effluent gets into the mainstream. And finally, the rainwater, which comes from the sky and which also rolls down along with the rest of the water, and that gets into the stormwater drain. So this channel is actually common from now, this point onwards. So this is the stormwater drain, which actually therefore carries a combination of treated sewage from these sources, as well as the effluent, treated effluent that from these sources, and rainwater. It's a cocktail of all three parts, and then it gets into the stormwater drain. So depending on which city you belong to, the cocktail changes throughout the year. In Bangalore, it rains 7 months, and there are 60 wet days. So 60 wet days carry all the rainwater, of the year. And we get, therefore, at any given point of time, the approximate ratio of the sewage or effluent to rainwater is 1:9 or 1:10. That means on a wet day, on a rainy day, we get 10 times rainwater flowing in our city stormwater drain as compared to the dry day flow. So that is the situation. So the water volume flowing in the stormwater drain swells by a factor of 10 on a rainy day. So it might be a difference in your city. If it's a coastal city like Chennai or Mumbai, it will be a very heavy rainfall, and so there you will have a different figure. So coming to this common channel, we have stormwater drains, we have wetlands, that is the biological nutrient removal stage. Then we have the channels which carry all this water. In Bangalore, we call it Rajakaluve, but it may be called something else in your city. And then there is a chain of lakes. In Bangalore, there are multiple lakes cascading into, downstream lakes. And therefore, we talk about lake chain, which is the lake and channel, a combination, a repeat of that linkages throughout, the city. And through all of these elements, there is a leakage, there is a percolation of water into the groundwater. So all these are our assets. The STPs are our assets, the underground pipeline, the sewerage network is our asset. The private STPs and the public STP, both are our assets. The effluent treatment plants are also assets, either belonging to some private party or it may be a public infrastructure. And so all of these are assets, and we have to actually talk about it. We have to plan for it, and we have to take them into account while talking about the integrated water management for the city. And so, similarly, the stormwater drain, wetlands, and channels and lakes, everything is, all these belong to our assets. And so is the groundwater. Groundwater is the most critical asset, and we have to protect it from pollution and pathological, vectors. So this is the, overall overview of the system. I would like to take a question if there are any at this point.
Go ahead. I would first invite students to speak up. We can then have faculty members. Any questions for Nagesh sir? Okay.
Shall I go ahead?
Just one moment.
Should I stop sharing?
No, it's okay. It's okay. Just one moment. Let's see. Will AKASH or Dr. ANSHY, anyone like that, have anything to offer as comment at this stage?
No, sir. No comments at this stage. Yeah. Please carry on. Yeah. It's very interesting.
Okay.
Thanks. Go ahead then.
So, coming to lakes. Now, why we are talking about lakes? This was actually primarily based on in Bangalore, because in Bangalore we have many lakes. We do not have a river. But in even cities like Mumbai, Chennai, and other places, there are rivers which are only one or two rivers in the city, and the remaining city also has lakes. So it is relevant to talk about lakes in a separate category. And because the lakes can be controlled, they are looked after by surrounding community. They have a different dynamics compared to a river, which primarily may flow through the city. It may be coming from outside the city. It goes outside the city. So it basically not seen as a complete asset belonging to the city itself. So there is less public support in controlling the health of a river as compared to a lake, which is seen as a local asset or a local property. So I will just highlight this. You may apply it to rivers also, but this is what this one. So traditionally, a lake was seen as a single unit. So I mean, we normally take a lake is a lake. What is there to see? But as you see, there are almost 36 or 39 different assets which are there in a lake, which can be divided into 3 specific zones, I think. So the left side is ecological zone. All these assets basically belong to a lake and which provide ecological support or ecological function in the lake system. Then comes the lake periphery, which are basically some other assets, supporting assets. And then comes the social zone. The right side social zone is also important because that actually attracts the public to the lake and keeps it safe from antisocial elements and dumping of garbage and things like that. So public participation at a lake and public presence at a lake is very critical. And that can be only ensured by offering the surrounding public some attraction. And that is the social zone we are talking about. So social zone has garden, trees, bushes, butterfly park, walking tracks, running tracks, and so on. Gazebo, amphitheater, children play area, recreation facilities, and Kalyani, which is, a kund, which is used for immersion and some, puja and other facilities. Whereas the ecological zone on the left is the main thing which actually, plays a part in the health of the water body. And that is where probably the chemical engineers among the audience may be more interested. And the health is maintained with separate assets, different assets, like silt trap, debris trap, an STP outside the lake, then a wetland, the stabilization pond, aerators, that is a diffuser type or peddler type or fountain type, fish cage, fish barriers to prevent fish from escaping from overflow from the west weir, bund, rock line of the bund, islands, west weir, sluice gates, and so on. So these assets basically play ecological role at the lake. So we have to maintain and we have to keep track of all these assets to ensure that all lakes are in good health. So this goes way beyond a chemical engineer's interest area, but this is it would be very good to keep it in mind that this is the overall picture in which they are playing a vital role. Now I talked about stakeholders. So how many stakeholders can a lake have? So actually, there are multiple stakeholders. There are some government agencies, there are communities, and there are other livelihood people who are also dependent on the lake. So I will not go into the detail because some students may be outside Bangalore, so they will have a different picture. So I'll just give an overview. So custodian of the lake is a government department or a local body which is custodian of the lake. They maintain the lake. Then there are bodies like BWSSB, KSPCB. These are all regulatory bodies. Lake activists is one group which is interested in working for the lake. Corporate donors, corporate fund manager, which is a separate entity from the donor. Community around the lake, which are interested in the lake for various activities, may it be religious or maybe it is entertainment or whatever it is, or bird watching and things like that, or other interests. There are farmers, there are fishermen, so they are dependent on the lake for their livelihood. So these are the stakeholders. Anything to do with the lake basically has to take into confidence all these people. So that is why the stakeholder identification and their win conditions, which are listed here, they are very important. Like what do they need? And if any chemical engineers from this group actually wants to approach with a proposal, he will have to keep it in mind that it is not only the stakeholder or the custodian of the lake who he has to win over, but all these stakeholders that he has to keep it in mind. Okay, so what are their win conditions also he has to keep it in mind, and he has to design his solution in such a way that everybody is more or less happy and nobody objects to the proposal. So many of them also have conflict, and these conflict is M by N type of many to many conflict. So I'm not going to get into the depth, but suffice it to say that different people have the different types of needs, and those needs are not always aligned. So these things also matter for anybody who has a solution in mind and who wants to propose a solution for the lake. Now the problems. Again, the primary focus is lakes, but it can be applied to rivers as well because they are all, after all, water bodies. So problem with the lakes and stormwater drain. First, no aquatic life. If you see, most of them are so polluted, there is no aquatic life. Enclosed heavily, not protected with fence or marking. It is not possible to detect encroachment. Sometimes we realize very late that some lake is actually encroached and some part is lost already. Encroachers, even if they are detected, are not evicted. They are full of sewage, heavily silted. Silt is one more problem because the water capacity or the carrying capacity of the lake actually decreases with the volume of the water. So this will be of interest to even chemical engineers, because if the water body decreases, the chemical dosing and everything else actually plays a part in that. Secondly, the silt, actually the more the silt, the different is the interaction between water column and silt column. So you have to keep that in mind, that what is the siltation state of a lake. It is littered with plastic and C&D waste, construction demolition waste, because what happens is the lake is at the neglected area, so people around are encouraged in dumping their garbage, and infested with vegetation and algae. So this is one more aspect which chemical engineers can directly deal with, probably. Polluted with industrial effluent. Again, maybe this is a interest area for chemical engineers. Foam and odor, problem, because again, this is a secondary problem related to the previous issues. So these are the problems. And problem with the water system management is a lot of money is wasted with no outcome, because every year we hear that government is declaring 500 crores, 10 crores, 15 crores per lake and things like that, but we don't see any outcome. All stakeholders are unhappy because none of them are being involved. Stakeholder needs are not met, let alone balance. The balancing and removal of conflict and all that basically is not done. No response to individual complaints. No response to CSR donation offers. Because there are people who are ready to donate, but they are not taken up by the lake authorities. No clarity about budget. How much budget is allocated and how much is spent out of it, that clarity is not there. So we can't talk about what happened. No clarity about long-term or annual goals. So for example, in Bangalore, every year, every month, the Karnataka State Pollution Control Board declares that the category, the categories to which each lake belongs. So 2/3 of that scale actually is from A to F, where A is the best quality water, F is the worst quality water, and the categorization is declared every month by KSPCB. And the situation is that there are no A, B, C category lake in Bangalore at all. And of all the lakes, 2/3 belong to the D category and 1/3 belongs to the E category. So it is like the last two categories dominated, in the lake health assessment. So there is no long-term goals. Like for example, a few of these lakes are being taken up, and it will be converted from D to C, or E to D, or C to B, or C to A. That type of goal is not declared, and that then there is the corresponding cleaning up of the lake or chemical processing of the lake, and such activities are not launched. So we neither have goals nor neither long-term goals nor annualized goals based on this. So as a result, what happens? KSPCB goes on reporting that all the lakes belong to D and E category. There is absolutely no change. And worst of all, whenever a lake is rejuvenated, there is no change in the water quality. If you see the statistical data belonging to all the lakes, and if you segregate them into rejuvenated lakes and non-rejuvenated lakes, we don't see any difference. No action plan in public domain. They are not put in public domain. False promises are made, but they fizzle out routinely. This is one more issue. So what are the root cause of the problems? Water pollution. So we see these are the main problems, garbage in lake, macrophytes, means, macrophytes and microphytes, either algae or water hyacinth and other plants are growing in the lake. The lake is not clear. There are fish kills. Frequently we have massive fish kills. Heavy metals and chemicals are found in the water. There is a stink and the lake is heavily silted. These are the main complaints. And these are the root causes of all these problems. So I think in the interest of time, I will not actually get into this one. But what happens is finally the root causes are further, they have their own root causes. So ultimately we stop at these yellow boxes, which says there are, these factors are responsible for finally all these problems. So number one factor is the solid waste management service is either missing or poor around this lake. So what happens? The garbage actually lands up in the lake ultimately. Second factor is lack of tertiary treatment of the treated sewage, either because of the STP is not working properly or it is not there at all. Same thing, lack of STP and malfunctioning STP. Lack of effluent treatment plant in case of industries, and no protection against erosion. And there is one more factor which is contributing the so-called silt, which is the human excreta. There is a solid component in the human excreta, and it actually gradually goes into the lakes and settles there. So we call it silt, but in the city environment, there is hardly any erodible soil. So what we get in our lakes is mostly human excreta, which actually goes and settles there. So that is one more factor, and for which we do not have any protection against that, like how to trap the human excreta from traveling to lakes and settling there. So these are the root causes of water pollution. Now, many lakes have disappeared. In Bangalore, 20 lakes have disappeared already. And there are other lakes which are earmarked as dead lakes, and which the BBMP was actually thinking about handing over that lake for public, the real estate development. So what happens, instead of contributing to the water scenario of the city, it is actually becoming drain for the water, or it actually contributes to the pollution. So from the asset side, they are switching to the liability side. That is the problem. Now, what are the root causes for that? So there are two problems. One is encroachment of lakes and drains, and the other one is lakes going dry and therefore ultimately declared as dead. So these are the root causes again. So I will focus on the yellow parts. One is maps are not in public domain. Say Google Map, if you see, the lake boundaries are not marked in the Google Map. So if you see Google Map, you will not realize that you are standing in a lake property. So it is very easy to encroach. And if there is an encroachment, there are no eviction. Sometimes it is because government says that these are all very low income groups, or people who are migrants and things like that. So on humanitarian grounds, the so-called humanitarian grounds, they stop eviction. And poor urban planning. So our urban planning, our land use policy, first of all, there is no land use policy across India. No city has land use policy. We have only land use plan. Now, how do land use plan get generated? Nobody knows. It's an ad hoc plan, right? And so in ad hoc plan, there is no respecting of these natural assets and no working around that. No policy as to how we will respect it, what kind of buffer zones are required, and so on. So, for example, last week, government came out with a buffer zone policy, which was roundly castigated by all the experts and activists in one voice. So this is what happens when urban, planning is missing. Then for lake going dry, there is a lack of public STP. So what happens? The polluted water gets in and they get diverted. Once the water gets diverted, this rainwater which comes to the lake also gets diverted. So the lake becomes dry. So even if natural rainwater was coming earlier, the mixing of sewage becomes a curse. And then we divert everything, the whole cocktail, and let the lake go dry. And second problem is we do not actually do water balancing. Again, this topic was of particular interest to the architectural group, but in chemical engineering group, this we will have to see from another perspective. Now, another problem is groundwater stress. So we just now saw on the lakes. Now there is groundwater stress also. Every month, every day, Bangalore uses 700 million liters of groundwater. It extracts and uses for daily consumption. 700 million liters per day. And as a result, there is a permanent subsidence of ground. What happens when you take out water from the aquifers, underground aquifers? The ground actually settles gradually. So this causes a lot of issues in the world. Can you see these pictures? Can you see this picture?
Yes, sir. Yes.
Yeah. So this is from California, where they measured. In this picture, you see in 1925, the land was here. In 1955, it sank to this level in 30 years. And in 1977, in 22 more years, almost like 22 more years, it sank to this level. So this is the level of land sinking. This is happening in Bangalore also. You see the second image where land is sinking and the bank of a canal is now breaking up because of that. Here you see the entire channel has sunk because of subsidence. And here in this picture, 65 to 2013, the land sank from this level to this level. So this is what is the permanent effect of land water extraction. In California, it is very heavy. So this is dramatically seen. Bangalore is also seeing. Fortunately for Bangalore, our underground structure is actually rocky. So we do not see this type of catastrophe. But we are also, facing that on a long-term basis. So groundwater stress is caused by multiple factors again. So this chart actually shows the breakdown of different factors. Okay, I think for chemical engineers this may not be of much interest, so I will skip the details of it. Again, floods also have similar problems. So why we have urban floods? That also has lot of factors, mainly divided into 5 different category. One is lakes related, other is drains related, third is road related, fourth is terrain related, and fifth is climate change related. So all these factors put together causes flood in Bangalore or other cities as well. And if we reverse or eliminate these root causes, we can actually get rid of these floods. So again, primarily of interest to the architect group, but probably not for the chemical engineers. Finally, the organizational failure, institutional failure, which actually plays a very vital part. We saw all these various kind of group, and the question comes as to why the government has not taken care of this, right? So that is because of this institutional failure. So in a normal organization, there are here you see 2 blocks. One is called organization. The below block is called institution. The difference between these two is institution has to be a well-run organization first. Then you add public transparency and public participation to a well-run organization, and it becomes an institution. So this is a gradual, transition from organization to institution. But if you look at all the, the agencies like BBNP, BDA, KSPCB, you name it, all these elements are missing. So that is why you do not have a reliable organization which can plan and achieve all these targets, whatever is function is assigned to them. And that is why we have these problems. So these basically I had listed, what things are required from different stages or different stages of the organizational process. Here, I'm not going to discuss that, but by the way, I have actually written an article on this. It was primarily meant for the lake activists, and so it is there on opencity.in. We can share the link later on. But coming back to our topic, apart from individual weaknesses in individual department, there is the lack of interdepartment coordinations. And there are at least 9 different agencies which are playing a part in, Bangalore. In different cities, it will be again, counterparts in their cities. So all these actually, they work in silos. So they do not coordinate with each other, and that is why there is a coordination problem. And anybody who wants to contribute, he has to run from pillar to post, so he is quickly discouraged. So that also has to be taken care of. So solution, I'm not getting into individual solution, although I have a slide, but not for this audience. So solution is to, block all those components which we talked about, and we have to then take care of individual components, so we can solve that. Now with this I come to the end of the presentation.
Thank you, Nagesh. First I will invite Niranjan Khatri to share some thoughts, then we will invite AKASH and others. Go on, Niranjan.
Yeah. My message to the students is you're very lucky to have Mr. Nagesh ARAS speaking to you when you are in the college. I hope this knowledge will be internalized by you, and you will fine-tune it by first starting a water audit in your own campus and see how much water you're using and what are the opportunities for saving. And the opportunities are huge. And most of the time, we're not able to do it because we don't form a kind of a core group in the college which looks at these issues and then takes permission from the higher management to implement it. So if you can do this in your college and also in your respective homes, you can reduce water consumption by 50%, if not more. Thank you.
Wonderful. As always, very crisp and short. Well, the teachers next. Any one of you? ANSHY or AKASH, anyone who wants to respond? What do you think is the takeaway today? And how can students, like our Mr. Niranjan Khatri said, how can students be inspired into some action on that? Yes, please. AKASH? ANSHY? Anyone among the students who wants to raise hands?
Hello, sir. Am I audible to you?
Yes, you are.
Hello?
Now, yes, you are.
I think, sir, for regarding our students, I think there are a lot of competitions, design hackathon. So I think they can get a lot of inspiration from this particular talk regarding the water infrastructure. So currently we are insisting our students to take part in all the national and international events. So I think they can this is something out of our expertise. What you say, we are more, I told you, sir, previously, we are more into the application or treatment side. So this aspect is this is something from interdisciplinary thing for us. So if they are incorporating into it's like enhancement of their skills Like, especially, I think it will benefit the students, especially when they are doing a project or when they are developing a model or a prototype point of view. They can directly develop a technology rather than focusing on single aspect. It will give a multi-dimensional thoughts towards the student.
Right. Good point. To the students, I must say that one of the slides Nagesh sir showed you low DO. You know what DO is, right? When in a lake we are talking dissolved oxygen, what does that mean to you as a chemical engineer? I don't need responses. I want you to think about it. The other is, he also talked about, in the chain of consequences, he talked about algal bloom. For want of time, he did not expand on that. Now, what is algal bloom? How can you take a lake probably around, in your area? If you went to Vembanad, you know. Who is that? Yes, Akash? Yeah. So, Vembanad has a serious problem of algal bloom, not today, for the last 15, 18, 20 years probably, right? The other thing he talked about is the non-functioning sewage treatment plants, and these sewage treatment plants, or at least the technology for it, is coming from people like you who are chemical engineers. You are the culprit of such things, okay? Now, what is therefore the regular tertiary treatment process? Why are STPs failing? Please ask these questions. You have to go beyond your classroom and exercises. You have to understand what is happening outside in that world. There is 40 billion liters per day. Yeah,
yes, sir. Last year, our PJMT, I think Karina presented an idea. So it was, actually we got, like my student got prize in PJMT, national round. She was the first runner-up. So at the time we were proposing a technology that can replace the current tertiary system. That means we were proposing a chemical oxidant-free oxidate. That means we will not be adding any chemical. We will in situ generate hydrogen peroxide, and we were proposing a technology. So I think that technology is
I heard that presentation.
Yeah, sir. That technology is ideally suitable for algal bloom also. Like, by keeping 2 to 3 aerators, we can in situ produce H2O2.
So why don't you encourage it to make a business case out of it in a way that it can be given to some local administration with the economics for it?
Currently we are working on the large scale treatment system. Recently we have received a funding from Ministry of Environment and Forest. So we have got a prize in national level Idea for Life Challenge. So now what we are planning is, like, we are planning to develop a 100-liter treatment system, sir, to check the practicability with the real water. After that, we are planning to propose this thing. So we are in the stage 2, sir. Like, initial trials, everything is over. So now we are planning for a technology development, sir. So this year we have assigned a new group of students. So we have started the work, sir. But there are a lot of challenges others. So I think we may take some time.
No, good.
But we are on the track, sir. Like, we are addressing all these aspects, sir.
Wonderful.
If this team has got multidisciplinary inputs, like somebody some limnologist or biochemist, I'm sure you will have biochemistry within your campus, right? So that is covered. But limnology and other aspects are, if they are covered, then we have to talk about other aspects as well. For example, allelopathic competition between macrophytes and microphytes. That is something you have to take care of. It cannot be a sort of a blinkered idea about treating a lake for with some herbicide or something like that. So we have to find natural solutions which are better accepted by government as well as activists also. And so there is a huge potential for chemical engineers to work on this field.
Yes, sir. And sir, we are doing the simulation aspects, sir. Like, we are studying the interaction of pollutants on different organisms like fish, algae. These all things we are studying via simulations, sir. Like, we are using Environmental Protection Agency. One simulation is the RICO, sir. So, like, in our recent study, it was on remediation of pharmaceutical compounds from wastewater. So after the treatment process, like it's a reaction, no, sir. Like if it is an oxidation reaction, it will convert into a lot of organic compounds. So we have identified all the organic compound using HRMS analysis or LCMS. Then we have done elucidate the structure, and we have done the toxicity studies. Like we have taken Daphne, like fish, green algae, brown algae. So we have limited our study to few organisms, but we have successfully done the simulation study. Like we have proved that our technology is not creating any toxic byproducts towards this marine life system or aquatic life system, sir. So we have started
brown
that
algae, you
also
mean
because...
diatoms?
What, sir?
By brown algae, you mean diatoms?
No, sir. It will only predict, sir, like whether it is toxic or non-toxic, sir. But we can know more about mutagenicity, bioaccumulation, bioconcentration. All these parameters can be determined, sir.
Oh, wonderful.
And he is only talking at the simulation level, not at the doing level. Simulation level only.
Sir, it is a simulation, sir. Like we have to just do the LCMS analysis, sir. Based on that, we have to
now
draw
I was
a degradation
clarifying to
pathway.
him since he asked about whether it's a diatom, I have to clarify to him. Okay, go on.
Yeah, sir, sure, sir. So this is a new technology, sir. I think in India, I think very few people have started this particular topic. Like in IIT Kharagpur, they are doing. Then I am a PhD. I submitted thesis from PhD NIT Rourkela. So in NIT Rourkela, like we two research groups are doing this. So with the support from NIT Rourkela, I have started this all things here. Like what all I have done in my PhD, I have extended this into the higher level. Like
lovely.
With the support of my supervisors.
Nice. Any other thoughts? Any last thoughts from you, Nagesh, Aras, so that we can then...
No, actually, I was thinking of when they talked about, the practical aspects of it and something like hackathons and all that. And now, I have participated in other college hackathons, which are wonderful. And so I was looking forward to this kind of interaction also with community-based, and where we can put together community and other, researchers and everybody. We can bring in toxicologists, limnologists, and then, put them together in one room so that, we can launch some practical projects from the students, actually.
Sure. Would you want something like that, Akash? Would you welcome something like that, where, you form some kind of a cohort, let us say, and work with Nagesh sir? Akash, yes? Or Dr. ANSHY, one of you can respond. Okay. Now, well, the students, I think we should get to some closure.
Somebody raised a hand, actually. Bashir or something. Okay. Yeah. I was actually presenting at that time.
Bashir,
Bashir.
There's nobody by that name here just now. I'm looking at the list. Pavan Kumar, are you the person? Can you just raise hand if you are from the person, the professional from Dehradun, Pavan Kumar? If you are, then I'd like to invite you to speak. Pavan Kumar? No. Okay. Anyone else who wants to speak up? Sarala Shanti is there. She's from a college somewhere near Bangalore. And I'm sure she resonates with the idea of so many engineering students who are present here today. Sarala, I've been telling you for quite some time that you need to see how you can take to some of these pragmatic, practical, on-field, on-ground kind of initiatives of the kind that Akash is talking about, or Nagesh is sort of expanding upon, whether it's lakes or other issues which have to do with water infrastructure, urban or otherwise. Students have to take it up and teachers have to see how they can encourage it. And then, of course, the industry will come, and then there will be this interface between academia and industry. Okay, does anybody else who wants to say anything? Professor Shweta, you want to speak up? Is that Shweta Jinjanwala? No. Shweta, do you want to say hello? Yes.
Yeah, yes. Sir is here. I'm good because I missed something came up from the class, so I'm good. Thank you.
Okay, all right. Well, then I think we should close this meeting if no one has anything to offer beyond this. Unless, of course, Professor Shweta, you want to say something. You want to say something on this whole concern on water, cities, infrastructure, and students? No. You want to say something? No. Okay. All right.
I just want to say thank you to
Yes,
Nagesh for the presentation. It was very insightful. I had a lot of young students joining from my team also. So it was very, very informative. Thank you very much. Really enjoyed
lovely.
it.
You have other students too. I didn't know.
I have a lot of interns currently working. So they all joined this.
They're all present here?
Yes, they did join.
Yeah, lovely.
They're too shy to ask questions. So I think we'll leave it at that. But they're
all young Indians.
That's the most important. Yeah.
That's right.
Had I known that they were chemical engineers, I would have brought another deck actually. But this was actually meant for architect students, in fact. So I'm sorry. I was told that this is architectural batch. So.
Okay. So you have a flight, and I think we should close now. And you said 4:30 is your whatever hard stop. And Yatin, do you have anything to add? Next month, I'm telling you all, there's another wonderful person. He's a sustainable architect. I mean, architect who practices sustainable architecture. And he will be presenting some things that I think it will be, whether you're an engineer, or an architect, designer, whoever you are, as long as you are a young Indian. I'm telling you, his will be very inspiring. It's coming up on the last Friday, I think, of this month of August, that is. And well, you will get the invite. It's up to you to see if you're interested, and students are invited to also be present there. If there's nothing else, I think we should sign off, and look forward to meeting you all again.
I see a big student community, so I just want to say thanks to everybody for joining and staying on. I haven't seen too many drop-offs. I think that was very, very good. Thank you.
Thank you so much, all of you. Yes, we'll sign off then, Payal. Yeah, we will. Yeah. Thank you, Nagesh.
Thank you.
Very good to have you here. After a long time, this finally happened. No. Okay. Thanks. Bye. Bye. Thank you, Niranjan.